Hello, so we are back, and this time we have a proper nice laptop to repair. Asus Vivobook i9 and NVIDIA RTX Studio OLED screen. What do you think about this laptop? Proper nice. Pressing the power button, nothing happened. The customer also sent me, this is a replacement charger, it's not a genuine one. Anyway, the customer is a computer business. Let's check the customer email. So the customer is saying, I have Asus Vivobook Pro 15, no longer seems to charge. So the laptop is not charging, but it's not saying if it's working or not on the battery power. What do you think? Can we fix it? I will say, let's open the laptop. Well, actually, there are no screws here. Okay. Oh, the laptop, it's open. Yeah, that's a nice motherboard. I mean, I really love, chipset with heatsink. Proper nice. The battery is connected. The charging port is here. And I don't know how we can approach a repair like this. We should use the original charger. We should use the power. Using the power supply, we don't have here access to the pins. Let's unplug the battery and let's check the main power rail just to be sure it's not shorted. So the main power rail, we have some capacitors here. Not sure if that's not sure about that. Coil, MOSFETs, capacitor, and it's not short. We have an electrolytic capacitor here, but here we have 0 ohms. Another electrolytic capacitor here, but here is fine. Current sensor, fine. Capacitor, fine. Another capacitor, fine. So I believe the main power is not shorted. That's what I believe. In this case, I will say let's plug the battery, because I need to know. Yeah, we need to know if the laptop is working on the battery power, and that's important. It will tell us a lot of things like, okay, the EC chip is good, the CPU is good. So we have ground and we have plus on the battery. And yeah, the battery is charging. Check there. 1 amp on the battery. 1 amp. Let me raise the current. Yeah, 2.4 amps, you can see. But the battery is very discharged. We have like 10.9 volts. You can see on the other side. Yeah. It will take a while to charge this battery. I'm gonna edit and cut forward this video. Okay, we charged the battery a little bit. The voltage reached 12 volts with 3 amps. Let's see if the laptop is coming on. Pressing the power button and nothing happened. No. You think the battery is too low? Battery voltage 10.5. Main power rail voltage 10.5. 10.5 is not enough for the laptop to start. 10.5? 10.5, yeah. It's too low. Let me push a little bit more current into the battery. One second, why here is warm? So here is cold, cold, cold. Obviously the laptop is off. But here I can feel something warm. Why I checked? I checked because it's strange the battery to be that discharged. Let me take this metal out. And this heatsink is out. Thermal pass, chipset. No, it's not a chipset. I have no idea. Let me grab the thermal camera. Oh wait, the battery is not connected. So with the thermal camera, yeah, something here inside. I can feel it. No, it's not the chipset. No. With the thermal camera, what is that? Check that. It's exactly under this metal. Can we take this? Yeah, we can. We can take it out. It's a chip. Check that. This one. Yeah, yeah. Kind of hot. Okay, so what that chip is doing? Anyone knows? No one? We should grab the schematics? We don't have a schematic. Let's figure it out what that chip is doing and why the chip is getting hot. Going under the microscope. So what that chip is doing is sitting there. Looks like a power supply. You are thinking to what I'm thinking? LDO power supply, you said? I mean, I can't even see what he's saying on the chip. I mean, this chip is getting power from where? Here we have 0 volts. Here we have 5 volts. Here we have 10.4. Okay, so this chip is taking power from the main power rail and looks like it's providing 5 volts. And I'm assuming on the other side here it should be 3.3 and it's like 1 point something, 1.7. So this is the LDO power supply. Yeah, so definitely here should be 3.3 and it's 1.7. We can check on the AC chip. I'm pretty sure it's the LDO. If we have 1.7 on the AC chip, that means should be 3.3. So here we have, check on the screen, 1.8, 1.7. You see? Why is that? Because the LDO power supply can supply with max 150 milliamps and something is short and it's taking too much power. I mean, okay, that chip is getting hot. But if something else is shorted, like the AC chip, and it's not, check that, the AC chip is not getting hot. Okay, this is strange. Let's do something. Yeah, definitely should be 3.3 there. Okay, let's disconnect the battery. Let's check the coils. So the coils, this one is fine. 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 Everything looks okay. IT5571. Yeah. Then here we have 8 ohms. And here we have 0. 1 second. So on this capacitor, we have 8 ohms. That means on this chip, this one, here we have 8 ohms. You see, 8 ohms is not okay. So I'm gonna come with the power supply. If this chip is getting hot, it's faulty. If something else is getting hot, means it's another problem. So here it's taking 140 milliamps. 140 milliamps. Let's see what is getting hot with 140 milliamps. It's not the AC chip, huh? That's interesting. It's not the chip. That's crazy. So what is the problem then? No, it's not the chip. No, no, no. That chip is normal to get hot. It's normal to get hot because can provide only 150 milliamps. And check here, with 1.3 volts, it's taking 140 milliamps. If I'm raising the voltage, like what? Was 1.7 or something like that? That chip will get hot and it's normal. Feels bad, man. Let's take the heatsink out. I'm thinking to the LDO, can be used for like RTC line for the CPU. Yeah. So let me get the heatsink out and let's check together the CPU. No, because the RTC line is to the chipset. It's not to the CPU. 1 second. 1 second. No, we are focusing on the wrong direction. No, we have to find what is taking that 150 milliamps. That's the only chance. So this capacitor is taking 150 milliamps. Let's raise the voltage. Yeah, it's taking 170. You can see with 1.7 volts. And what is getting hot, I had no idea because nothing is getting hot, which is impossible. The thing is, the heatsink seems to be warm. Wait 1 second. We don't need a power supply because we can plug the battery. Yeah, we can plug the battery and it's doing exactly the same thing. No, actually it's not doing the same thing. With the battery plugged in, I can't see anything hot here. The chip is getting hot. Yeah, that's normal. We established that. Yeah, you're right. The diagnose is the hardest part. Repairing is coming. You know what? It is something hot here. But I think it's on the other side of the board. You can see, so check that the board is warm. No, here is some reflections, yeah? It's not hot. We have some shorted USB port. No. I can see now we have USB-Cs there. We have to take the board out. Or let's take the heatsink. Yeah, let's take the heatsink out. Now, I am happy it's not the chipset and it's not the EC chip. Something connected to 3.3 is partial shorted. Partial has like 10 ohms, you remember? Yeah. And the heatsink is out. Let's plug the battery again and let's check one more time. Yeah, that chip is still getting hot, but the CPU is fine. Yeah, GPU of course is fine. Chipset is okay. Good. Let's take the board out. And the board, it's out. I forgot the keyboard. And there's no liquid damage, nothing. Ha! Ha! Check that. Check that. Can you spot the fault? Just tell me if you can spot the fault. Huh? You know what is that? That's the lead sensor, and the lead sensor has 3.3 on it. Yeah, that's the problem. But no sign of liquid damage here. Hmm? Also, the board, especially here, has a specific smell, like pizza. With chicken and pepperoni and. What do you think? Huh? What do you think? Smells like pizza? Yeah. Check here. Check here. How much damage? It's only because otherwise it's looking fine. It's no liquid damage on the board. Nothing. Only here, the only place where is the liquid damage. Yeah. Where is the lead sensor? And the lead sensor it's using 3.3. Now quickly let's clean it. No, I don't think the lead sensor is faulty. No, it's just liquid damage which create bridges. Yeah. Check that it's like new. And the lead sensor pin. It is fine. It is fine. It is fine. Let's dry. Good. Let's connect the battery. Yeah, remember it was getting hot. Let's connect the battery. That's all what we need, the battery. Battery is connected. It's getting hot? It is. That's crazy. Check there. What is that? You know what? Let's use some alcohol because I cannot spot the fault with the thermal camera. So a little bit of alcohol, just a little bit. So what is getting hot? That capacitor? Yeah, check that. So it's getting dry instantly. Yeah, this one. Say hello to my little friend. Yeah. What about now? Anything is getting hot? No, now nothing is getting hot. The chip is still getting hot? No, the chip is not getting hot anymore. You can see? No. The lead sensor is working. We can check together. Yeah. So the way you check the lead sensor, you come with a multimeter and you check the voltage. Very simple. You have input, output, and ground. So this one is 3.2. This is input because it was that capacitor. Here is 3.2. I'm assuming this is the output. So with the probe on the output, yeah, you come with a magnet. I have a magnet here. You can see. Check here. We have a magnet. And soon as you come close with the magnet, the voltage is going to 0. Check there. You can see. The lead sensor is a Hall sensor, a Hall magnetic sensor. Yeah. So it is a magnet inside of the screen. On the side of the screen, on the side of, not actually in the screen. And when you close the lid, this sensor is sensing the magnet, and yeah, this one is switching to 0. This one is going to the AC chip. Cool. So what do you think about that? What do you think about that? Can't believe what kind of fault we fixed. So the lessons to learn from something like that is don't be lazy, yeah, like sorry, and take the board out, yeah, from every laptop you have for repair and check, because it is possible to have like exploded component or liquid damage on the other side of the board. Now just give me like a few minutes to put the board back. Replacing the capacitor. Maybe on the next video. Maybe on the next video. Okay, all back in place. Plug in the battery. Good. So with the battery plugged in, we should have 3.3 on the same spot on the EC chip. If you remember, not sure if it was here. Yeah, check on the screen. 3.2. You can see. So the 3.3 is present. Probably the battery is too low. Pressing the power button. Yeah, most likely it's low. Yeah. Let me plug the customer charger. Yeah. And let's see with the customer charger. No, 1 second. No. We have light here. We have picture. That's crazy. Yeah. And it's loading the windows. Ha. Let's see if the percentage is going up. 3%, check that. So it's charging fine. We have 11 gen CPU and yeah, NVIDIA graphics. So what do you think? Tricky repair, right? Yeah. It was tricky, but following, the normal diagnose, like usually, we are checking the main power rail. Shorted, not shorted, present, not present. Then the next step, you check the 3.3 LDO. And the 3.3 LDO, it was partial shorted. Not fully shorted, partial shorted. Remember, we have like 1.7 volts on the EC chip? Yeah. Now, another lessons to learn is just because a chip is getting hot, that doesn't mean it's shorted. Maybe the output of that chip is shorted. Okay, so it's charging fine. We have like 5%. I'm gonna stop now. I will say thank you for watching. Like, subscribe if you like the video. And see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members-only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.